All right, you ready? Who was the? Oh, here. You got the envelope? Okay. Ready? Who wants to take the half? Who is the half? Okay, show it to them. The half, and then we have the. Who's the quarters? You can show the hands. Who's the halves? Sorry. Yeah, again. And then the fourths. Here we go.
It smells like fire.
What was that? Here we go. So we can show them so they can see. If you put them on top of each other. Ready? Come on up. Come on up. Okay, so here's the half, and then you can, these pieces fit on perfectly. And so they can see that the, also again, the going from the, you know what I'm saying, the using the manipulatives to then something like this that's extremely abstract, okay? But they do it, they'll get it, and it's, you know, second nature. All right, so let's do the next one.
Take that time to count just all the horses. They would not see that they're grouped together. They don't see that right away. So they go ahead and you count. So what I do with my daughter is they're grouped. I need you to count how many horses are in there and write on the bottom how many there are.
Sure.
And if you're doing it with each of the groups, the child will see that you're writing the same exactly number. And now when you're talking about multiplying, right, you need to be able to see that it is, I see 3 groups of 5 horses.
That's right.
And from that, we go on to, now we're going to go and multiply this. Put it in a different expression rather than 5 plus 5 plus 5.
That's right.
Because if you have, like I said to my daughter, if you have 10 groups and you're writing 5 plus 5,
exactly.
You're going to tell me, Mommy, my hand hurts.
And that's a perfect example.
And then, you know, I told her that now we're going to write that down in that expression 3 times 5, and then what is the answer, and she'll be able to tell me what it is.
That's right. And hopefully they have that skip counting strategy, because 5s is easy, right? But if I had 6s in each group, skip counting isn't so easy when we skip count by 6s, right? And that's what children in 3rd grade will do. As you said earlier, it really is 2nd grade that children learn to skip count by 2s, 5s, 10s, and then 3s and 4s, which are a little bit more difficult. So in 2nd grade, they learn that skip counting strategy. 1st grade, they learn that they can add repeatedly, 5 plus 5 plus 5. In 2nd grade, they learn to skip count 5, 10, 15. In 3rd grade, they learn to then skip count by 6s, 7s, 8s, and 9s. Using what they know about, you know, for example, you can skip count by 6 if you know how to skip count by 2 and 3.
Y se recuerdan la estrategia que yo le enseñé de subrayar la palabra, el vocabulario que ellos reconocen, enseguida subrayarlo, porque así eso lo ayuda a ellos a enfocarse en la pregunta antes de tratar de contestarla. Y en el tercer día no hay A, B, C y D. Ellos tienen que aplicar todas las estrategias que ellos han aprendido ese año en matemáticas. Imagínense.
Y escribir, explicar cómo cogieron esa respuesta, que es lo más difícil. Uno puede resolverlo fácilmente, hacer los números ya, pero explicar cómo sacaron esa respuesta.
Se recuerda, esa es la parte más difícil que nosotros empujamos a ellos que traten de lograr a ese paso, nivel. Eso mismo. Y explicarlo en sus propias palabras cómo llegaron a esa respuesta.
Paso a paso.
Sí, es mucho lo que se le espera a ellos. Es muy diferente a la manera que nos enseñaron a nosotros.
What is it? It looks like the
You have to put the line all the
looks
way
like the
through.
field goal thing fell over. Like after a college game when they tear down the goal.
Yeah, that's just off center, so it's all out of whack. See?
Well, Mrs. Mandela,
This
we're
is what would go off, right?
yes, we're stumbling through the work here.
I don't know who's doing it.
Why can't you simplify it?
Because 11 is a prime
A prime number, and it doesn't go into the denominator.
Yes.
Exactly right.
You have a good
Very
team.
good.
My turn.
So, next. Nice job.
So, common denominator of 4 and 3 is 12. And 3 times 3 equals 9. And
Why did you have to go past 17/12? What's wrong with that answer?
This is an improper fraction here, so I turned it into a mixed number.
And how'd you do that?
What I did was 12 goes into 17 once, and then I found out the remainder. I found out the remainder by doing a fraction in my head, which is 17 minus 12, which is equal to 4.
Nice job. Nice job.
Nice teaching too.
Nice work.
Future teacher, I think. Future
so.
teacher.
When the numbers are the same, you multiply, right? Because this is the way I tell them. I know all of my parts, but I don't know my whole. And I have the children physically move their hands because your children are very much into the physical stuff. They need to move. They're little guys. Sitting at a desk is not going to work for them, so they need to move. So they move their hands and they show it with their hands. And that really helps them to understand it. So however they want to do it is fine. It's fine. They just have to be able to prove. Some of you looked right at this and said 2 times 3 is 6, done. What we're saying to them now is, that's awesome. I'm so proud that you know that fact. Prove it. Prove it to me. This is your chance to be fresh, guys. Prove your answer is right. And they sit down and they will come up with 12 different ways to Sunday to prove it to you because they're just so happy to be proving it to the teacher.
Yes, I just
like
wanted to
that.
say, I know in some of our problems, I have a kid that will show 3 different ways because they love to, oh, I did it this way and I did it that way. They love to show what they know, and this is something that the kids really do enjoy. They get to draw their pictures, and they get different answers, different ways to show it.
This as well, I'm looking at the visual model. Now I'm going to turn it over to Mr. Ryder. Here we go. Okay, this is just another visual model. And here's a sample that came from the 2014 assessment.
Okay, so the fraction model below represents the whole unit. So again, they're going to give them a visual, which is part of the standard. So they need to see the representation and then use what they know about fractions and apply that to find an answer. So the question says, which number sentence represents the amount of the fraction model that is shaded? So they have to look at the fraction model and figure out how many is shaded. Does anyone know? Jamie? 1/3 of each, right? So it's not just 1/3. So 1/3 of each one is shaded. So how many thirds is that?
How many?
6 thirds. So now, again, they would know we have a hole here, okay? So anyway, so then what they have to do is pick the multiplication sentence that now would match that. So does anyone know which one would match?
Yeah, you got it. You got it. 6 times 1/3. That's it. So it's really not as bad as you might think when you hear multiplying fractions. They're going to have a visual model, so it's not going to be.
So again, they just have to kind of apply what they see to now something that they're going to do a little bit